In this video, we're going to take a look at the anatomy of a hyperbola. So here we can see the two different branches of the actual hyperbola, which are the solid curves that you see on the left and the right of the graph. Then we see these diagonal dashed lines. Well, we dealt with dashed lines before. These are asymptotes. We dealt with them in rational functions, in exponential functions, and briefly with logarithmic functions as well. Sorry, there doesn't need to be an S there. It's a singular asymptote. So we have two different asymptotes. All right. We'll talk in a little bit about how to actually find those asymptotes and how they help us. But like a vertical asymptote, it's something that we approach, but we do not touch and we do not cross. All right. And then we have the center of our graph. The center of our graph is right here. Okay, so that's the center of our hyperbola. A lot of times we're going to plot the center to help us figure out our measurements to draw the rest of the hyperbola. All right, but I'm not going to leave that marked. Now, the two most important points are right here, and those are the vertices. One, two, okay? So every hyperbola will have two vertices. All right, now how do we figure out where those vertices are? We have in between the vertices an axis, all right? And this is called the transverse axis. It's kind of similar to major or minor axis from an ellipse, okay? But here we have a transverse axis. It connects the two focus points, the two vertices together. Not focus points, we haven't talked about focus points yet. All right, the distance from the center over to one of the vertices is A. All right, so that distance is A, and that would go in the other way as well. So the transverse axis is 2A units long. All right. Then we have our focus points, okay? So we're going to put our focus points on next. So I'm going to make those purple. Now, I don't know precisely where the focus points are here, so we're just going to approximate where they go. I'm going to put it at negative 4.5 and positive 4.5 for the symmetry here, okay? So I'm going to call that focus point 1 and focus point 2, all right? And what we know about that is this distance is distance C, just like it was in an ellipse. From the center to the focus point is C. The difference here is now I can clearly see that the distance for C is bigger than the distance for A, which is the opposite of an ellipse. Okay. Now, back to the asymptotes. What we're going to do is we're going to construct a box. All right. Now, from the vertices, I'm going to start with the one on the left. I'm going to go from the vertex straight up until I hit the asymptote, okay? That distance is B. All right, I'm going to label it in a different spot where hopefully it won't be quite as busy, but here I have it again. That distance is B. So you know what? I'm going to go and put it right here. That distance is B. All right, I'm going to do the same thing on the other side. I'm going to go from the vertex straight up until I hit the asymptote, and from the vertex straight down until I hit the asymptote, okay? And then I'm going to complete a box out of this. Now, this box is a great tool to help us when we're actually drawing, but it's not something that we want to leave on the graph, okay? All right, now we have another line, another axis here. This vertical axis in this particular case, or perpendicular to the transverse axis, that is the conjugate axis. So instead of major and minor, we have transverse and conjugate, okay? So those are all the pieces that we're going to need to know for a hyperbola, all right? And on the next slide, we have something kind of summarizing all of those pieces together. So let's go through those bullet points together real quick before we move on to standard form. Okay. The center is the midpoint of the line segment between the two focus points. It could also be between the two vertices, okay? The points on the transverse axis closest to the center are the vertices. Those were our blue dots on our anatomy slide, right? The branches of the hyperbola, the actual hyperbola itself, will approach the asymptotes, but will never actually pass through the asymptotes. And the branches will and the asymptotes pass through the center of the graph, okay? The transverse axis is 2A units long, and it connects the two vertices. The conjugate axis is 2b units long, and it passes through the center and is perpendicular to the transverse axis. The focus points, the foci, are on the transverse axis. They are c units from the center, which is the biggest distance on our diagram. And then there's one more bullet point that got cut off here that we're going to fill in, and that is that for a hyperbola, we have a relationship. We have the relationship between a, b, and c is that a squared plus b squared is equal to c squared. It's back to being the true Pythagorean theorem. So for a hyperbola, when we're trying to compute things for a, b, and c, we're going to use a squared plus b squared equals c squared. All right, in the next video, we're going to talk about standard form of a hyperbola, and then we'll get into some graphing. See you there.